Okay, welcome back. Today we're going to talk about how to actually carry data between the scenes so that the player can have their data, how many stars they have on each level, what their score was, so that they can actually have that saved, so that they're not just able to access different levels, they're only able to access levels that they've unlocked, and the program will also save any high score or level data that they might have between those levels. So, first thing we're going to do, I'm in my splash scene here. I'm going to create an empty game object. I'm going to call this game data. And this is going to be a game object that persists between levels, which means I'm using something called the singleton pattern, where I have one object that's the same object between different scenes. And this object's whole reason for being is that it's going to bring data into the scene from an outside file, and it's going to save data from the scene into an outside file. And so that's what this is. I'm going to go to my scripts folder here, and let's go ahead and clean this up a little bit. I'm going to create a new folder, and I'm going to call this base game scripts. And this is going to hold all of my game scripts, like my board, my camera scaler, the dot stuff, finding matches, all of the things that work in the base game, I'm going to put in there. I don't have to worry about changing anything on any of the objects. The objects will still be able to find the script no matter where they are. I'm just making it more organized for myself. I'm also going to make a new folder here, and I'm going to call this game data scripts. How about? Oops, there we go. Game data script, and then in here I'm going to make a script called game data. Alright, and then I will open this up in C#, and I don't have Visual Studio open, so I will meet you back here when that's done. Alright, welcome back. So the first thing we need to do is we need to add a couple using tags here. First, we want to make sure that we're using system. Then we have to make sure that we have the ability to access files that are outside of the game. So we're going to be using system.io, .io for input output. And then there's one more, and I'm going to have to look this up to find out what it is. I always forget this one. It's super long. It's like 4 things. Okay, so this one is using system.runtime.serialization.formatters.binary. And the reason that we have to do all of this is because we want to have access to something that can serialize, which is a way of saying turn into something that Unity can read into a binary format so that it's secure. A binary format means that your game will be able to read and write from it. However, it's not going to be like a text file that's going to show up in your game project. It's going to be something that is at least a little bit encoded. You can encode it further by downloading some other libraries that you can use to create your formats so that your game save data would be even more secure. But I think this is fine for us. So, first thing I want to do is I want to make a little teeny tiny class that's going to be the game data itself. So I'm going to call this a public save data, public class save data. What am I thinking? And then in here, I'm going to save whether or not the levels are clear, what the high score is, and how many stars they've earned on that level. You can have a bunch more in your save data. If it's things like volume or whether the sound is on or not, just use player preferences for that. But so I'm going to do public bool, and this is going to be an array, meaning that level 1 corresponds to the 0 spot in this array, and this is going to be whether or not that level is active. Is active, and I'm going to do public int, which is also an array of high scores, and another public int, also an array of stars. So this is going to store the information about whether or not a level is active, what the high score on the level was, and how many stars were active. Now, in order for this to be turned into a binary file format, we need to make this serializable. And in the past, when I've done this with data classes, I've done system.serializable. But because I have using system up here, I can just do, in square brackets, serializable, because the system library has already been loaded. Okay, so now in my game data here, I'm going to make a reference to that saved data. So I'm going to do I can do it as private save data, and I'm just going to call it save data. I'm also going to create a reference to the class itself, but I'm going to make it a static reference. By making it static, I can call it from other classes without needing to first make all of those references to it. So this is going to be a public static game data, and I'm going to call it game data. Now, here's where the singleton pattern comes in. In my start method here, I'm going to say, first I want to check to see if game data is null. So if game data is null, then I want to don't destroy on load this .game object. So that means that when I load a new scene, this game object won't be destroyed. And I want to say that game data is equal to this just this. If game data is not null, meaning if game data already exists from the scene before that we brought it forward, then I want to destroy this .game object. So what that does is that makes it so that, let's say that we go from the menu to the game scene, which doesn't have one of these. It's going to take this with it, so we'll be able to save data. And then if we go back to the menu would normally load one of these. However, it's going to check to see if one already exists, and if it does, it's going to destroy the other one, so that there's only one, but there's always one, so long as we start in that splash scene. Okay, so I'm going to save my script here really quickly. Now, I don't want to do this in start, I want to do this in awake. So I'm going to change my start to awake, so it happens before any start methods. Let's see, I'm going to make a little method here called save, and I'm going to make another one called load. Oops. No, not on level was loaded. Good lord. Click away so that Visual Studio doesn't get too excited about completing. And I'm going to make both of these public so that I can save and load. Well, I'm going to I'll make both of them public so I can save and load from other scripts. Okay, so now let's do the save first. And I'm going to go through this piece by piece so that I can kind of explain what's happening. So first we're going to create a binary formatter. Create a binary formatter which can read, oops, misspelled which there, can read binary files. And so I can do this binary formatter because I pulled in this library here. And I'm going to call it just formatter is a new binary formatter. So that's just creating a new container to hold that binary formatter and calling it formatter. The next thing I want to do is I want to open up what's called a file stream, which is a route from the program to the file. So create a route from the program to the file. And so this is going to be file stream. I'm just going to call it file is a new file stream. Actually, I'm not going to do it as a new file stream. Sorry. So I'm going to say file stream file is file dot open. Why is it not letting me do that? I'm going to click away. Yeah, Visual Studio is just being weird there. So file.open, and I want to open application.persistent data path, and this varies from target platform. Like on Windows, it's in users/library/da-da-da-da-da. On Android and on iOS devices, it's somewhere else. It'll find it though. Plus, and you can name this file whatever you want to. I'm going to call it mine player.dat for player data, but you can seriously call this whatever you want to. You can call it, Smokey.thebandit. And I've got an issue here. Oh, I have to tell it a file mode. So file mode dot open. Okay, cool. So there we go. Now I'm going to say create a new version of player data, not player prefs. Player data is equal to a new player data. What is wrong with you today? Oh, save data. Ha ha ha. My notes are different from what I'm actually doing. Save data. It's not Visual Studio, it's me. Save data. Okay, cool. And then this is just to create a blank save data. And now I'm going to actually do the saving. So I'm going to take our binary formatter and I want to serialize. And now when I serialize, I have to tell it a stream to serialize it to, which is file. And then I have to tell it an object to serialize, which is data. And there we go. Now I need to close the file. File dot close. And this is lowercase f file, not uppercase f file. So let me comment that really quickly here. Actually save the data in the file and then close the data stream. And then I'm just going to add an extra debug log here. Debug.log saved. Now, this is just going to save data generally, but what I want it to do, instead of just generally save data, is I want it to save the specific data that we're using. So instead of setting my, let me just separate these here so it's easier to read. Instead of setting my blank save data to just be blank, I'm instead going to set it equal to the save data that I have in the scene. No. Save data. And there we go. And then instead of making this blank, I'm going to create a copy of my save data, which is called data. All right, cool. So now I'm going to add a little start method here. And I just want to save my data. That's all I want to do. Save. So I'm going to save my script. I'm going to pop back into Unity. I'm going to let that compile. And then I'm going to add my game data script to my game data object. When I hit play, you'll see a couple weird things happen. So if I hit play, first thing that's going to happen is you'll see this turn into don't destroy on load. I have my game data there. And could not find file. What did I do wrong? Okay, let me fix that. Okay, so I was doing it right the first time, I just forgot something. So new save data. So I'm back in my game data script in my save method. Save data is equal to new save data. I just want to do data equals save data. All right, let's save that. Let's hop back into Unity here. Let's hit play. Let that compile for a second. Okay, that was a dumb error. Sorry for that weird cut. So my save data here needs to be public, otherwise the formatter can't serialize it because it needs to take it outside of the script. And so because I had this private, that's where that error was coming from. So make sure that this is public so that then your save data can actually serialize it, send it out. So again, just to go over the steps really quickly here. We created a binary formatter that can read and write from binary files. We created a route to the file that we want to save to. We created a copy of our save data, and then we took that save data and we serialized it to that file. Then we close the file, and there's a little debug log here to tell us that we did it correctly. Now, if I save this and I go back into Unity and I hit play, oh yeah, the other thing, I did that off camera anyway. So it saves it. The problem is that we have no way of knowing that it actually saved it. So what I did, and I did this off camera, I shouldn't have done that off camera. Instead of calling save from the start method, down here I added another little void on disable, which is just whenever this game object gets disabled to save. Now, we need to actually be able to load the information in so that we can tell if our save system is actually working. So loading is a little bit more complicated, but it's not that much. So the first thing we have to do is check if the save game file exists so that we're not trying to load a file that isn't there. So we're going to say if file.exists, and the file that we're looking for is application.persistent data path plus, and now this has to be the same as you had it up here, so be cautious about that. I'm using player.dat. If you did, I don't know, hot.dog or something like that, then you'd have to do that. So player.dat. Oh, good lord, of course. Come on. IntelliType is driving me out of my mind today. Okay. And then, so we're checking to see if that exists. And if it does exist, come on now. Oh, that's why. There we go. All right. We're checking to see if that file exists. And if the file does exist, then we're going to load information from it. If it doesn't exist, we're just going to skip all of this block of code. So we're going to do the same thing. We're going to create a binary formatter. So binary formatter, and I'm going to call it formatter, is equal to a new binary formatter. And then we're going to say file stream. I'm going to call it lowercase f file is equal to file.open, no, capital F file dot open. And we want to open application.persistent data path plus / player.dat. And I need to get rid of this space up there. And file mode.open. So we're creating the file stream there. And then we want to change our player data. So I want to say my save data is going to be equal to the deserialized version of that file. So formatter.deserialize, and it needs to deserialize from the file path. And you could run into issues here because when it's deserializing that, it's deserializing it just as like a whole bunch of information. We need to tell Unity what to deserialize it as save data. Oh, yeah, I don't need an argument there. Just need to tell it as save data. And then now we can just close the file. File.close. And I'm going to add a little debug message. Loaded. Oh yeah, and close does need arguments. There we go. So I'm going to save this. Now, what I want to do is on start, I want to load that file. So if I save this, go back into Unity here, I'm going to hit play, and the first thing that should happen is I should see load, but I didn't have any data to load. That was kind of empty. So what I'm going to do is go to my game data here underneath don't destroy unload, my save data. I'm going to change is active to like 10 things. Mine says 100 things because of something I did off camera again because I'm a doofus. So I'm just going to change each of these to be 10. I'm going to change element 0 to be active, high scores to be 10 for element 0, and 1 star for element 0. Now, when I leave, it should save this information, and then when I hit play again, it should reload it. So, saved, and reloaded. So if I make a change here, it'll save it, and then when I reload the scene, that change will be saved. So this is the main idea. I'm going to have this be part 1. This is going to be a 2-part video. So this is creating the save system. Now we're going to make that save system actually do stuff, and we'll do that next time. So if you have any questions, please feel free to leave them in the comments down below. You can join my Twitter or follow me on Twitter to find out exactly when I post a new video. I have a link to a Discord that you can join where I'm chatting pretty much every day. And yeah, have yourselves a wonderful day.